Hello everyone, I am Himanshu Vasnani from Department of Mechanical Engineering. I am here to present a lecture on the subject non-destructive evaluation and testing. The subject code is ME419, unit number 3, lecture number 16 in the series. The topic name is types of transducers and working of couplants used in ultrasonic testing. So let us start with today's objective is to provide the students with a basic understanding of types of transducers and working of couplants used in ultrasonic testing. To know the working of couplants used in ultrasonic testing. Our learning outcome will be students will have an understanding of types of transducers and working of couplants used in ultrasonic testing. The students will understand working of couplants in detail in ultrasonic testing. So the transducer. We have studied about a slight idea of transducers previously also, but here I will go fast with the initial introduction of transducer. See, an ultrasonic transducer is a device that converts electrical energy and mechanical energy in the form of sound and mechanical energy back into electrical energy. Our purpose for doing this ultrasonic testing is to find the defects, the discontinuities, the you can say the voids that are left in the you can say workpiece. So for this, we go for one of the basic element of this arrangement of the ultrasonic testing is transducer. So ultrasonic transducer is a device that converts electric energy and mechanical energy in the form of sound. Okay, they convert electrical energy and mechanical energy in the form of sound, and the mechanical energy back into electrical energy. The transducers are manufactured in a variety of forms, shapes, and sizes for varying applications. The conversion of electrical pulses to mechanical vibrations and the conversion of returned mechanical vibrations back into the electrical energy is the basis of ultrasonic testing. Now, this conversion is done by the transducer using a piece of piezoelectric material and a polarized material having some parts of a molecule positively charged while the other part of a molecule are negatively charged, so that you can say with electrodes attached to two of its opposite faces. So when an electric field is applied across the material, the polarized molecules will align themselves with the electrical field, which is causing the material to change the dimensions. Okay. Now you can see in the diagram this kind of an immersion transducer. So in addition, permanently polarized materials such as quartz or barium titanate will produce an electric field when the material changes its dimensions as a result of an imposed mechanical force. So this phenomenon is known as piezoelectric effect. Okay, now the active element of most acoustic transducers used today is piezoelectric ceramic, which can be cut in various ways to produce different wave modes. Now, a large piezoelectric ceramic element can be seen in the image of a section low frequency transducer. So, the most important, or you can say the most commonly employed ceramic for making transducer is lead zirconate titanate. This is the most common used ceramic that is used for making the transducer. Okay, lead zirconate titanate. Now, the thickness of an active element is determined by the desired frequency of the transducer. A thin wafer element vibrates with a wavelength that is twice its thickness. Therefore, a piezoelectric crystal are cut to a thickness that is half of the desired radiated wavelength. The higher the frequency of the transducer, the higher the frequency of the transducer, the thinner the active element. Okay, the ultrasonic, you can say, transducers are manufactured for a variety of applications and can be custom fabricated when necessary. Careful attention must be paid to selecting the proper transducers for the applications. Okay, now it is important to choose a transducer that have a desired frequency because what application we are using. So according to that, it is important to choose a transducer that have the desired frequency, bandwidth, and focusing to optimize inspection capability. Most often, the transducer is chosen either to enhance the sensitivity or resolution of the system. So these transducers are characterized in a number of ways, which include, and the first is contact transducer. As you can see in the image, and the word says contact transducer, means something in touch, something in contact. Okay. Then contact transducers are used for direct contact inspections and are generally hand manipulated. These are hand manipulated. Okay. Now they have elements protected in a rugged casing to withstand sliding contact with a variety of materials. Okay, because the slipping should not be avoided. So they have elements that are in a rugged casing. Okay, the casing is so much rugged so that it can withstand the sliding contact. Okay, with the variety of with the all the materials that you want to test with these contact transducers. So the variety of materials they can withstand the sliding contact. Okay. Now these transducers have an ergonomic design so that they are easy to grip and move along the surface. Okay, the gripping is also important. So you can see in the diagram on the back rear side, some kind of you can say knurling is done. So it makes it easy to grip. Okay, and easy to handle also. So they often have a replaceable wear plates to lengthen their useful life. Okay. So coupling materials of water, grease, oil, and commercial materials are used to remove the air gap between the transducer and the components being inspected. There are various coupling elements like water, grease, and oil, or some kind of synthetic material is also used to remove the air gap between the transducer and the component being affected. Now, the immersion transducers. You can see in the diagram immersion, as the name says immersion, something is immersed. Something is immersed in a liquid. So the immersion transducer do not contact the component. Okay. Irrespective of the previous contact transducer, this is immersion. This do not contact the component. Okay. Now these transducers, this kind of like immersion transducer, these transducers are designed to operate in a liquid environment and all connections are watertight. Okay. They need to be watertight to avoid complications. Okay. So when they say that the environment is liquid environment for usage for operation, then obviously the connections are okay, watertight. Connections are automatically watertight. Immersion transducer usually have an impedance matching layer that helps to get more sound energy into the water. Okay, and in turn into the component being inspected. That is the most important thing. That the sound energy, okay, it should go to the component through the water. That is important. Now, immersion transducers can be purchased with a planar, cylindrically focused or spherical focus lens. Now, these are the kinds of available lenses, like a planar lens or a cylindrical lens or a focus lens. You can see on the right-hand side, a kind of a focus lens is used on the right image. So, now a focus transducer can improve the sensitivity and the axial resolution by connecting the sound energy to a smaller area. Okay, you can see that the focus transducer is very important. Okay, it has improved. You can improve the sensitivity and axial resolution by concentrating the sound in a particular area. As the name says, focus. So you can focus on a particular area. Now these immersion transducers are typically used inside a water tank or as a part of a squitter or bubbler system in scanning applications. Now dual element transducer. Now, this transducer is very important because you can see it in the name says dual element transducer. So it contains maybe two elements, okay, in a single housing. You can see in the diagram also there is an acoustic barrier. Then there are two different things. One is transmitting signal to crystal, and then the other is receiving crystal. And this all system is in a casing. Okay, in a case is there. And on the bottom side you can see the crossed beam sound part. And the bottom crossed beam sound part. So somewhere it has you can say there are two elements that are operating. And the operating may be like that, the one may be transmitting and the other will be receiving that. And they are receiving what they are receiving? They are receiving the ultrasonic signal. Let's start with this. So dual element transducers, they contain two independently operated elements. They contain these transducers contain two independently operated elements in a single housing, as we just seen in the diagram. One of the elements transmits and the other receives the ultrasonic signal. You can see in the diagram, this has told you that one of the elements is transmits and the other One of the element transmits. You can see the transmitting crystal. One of the elements transmit and the other receives the ultrasonic signal. See the diagram. Okay, now the dual element transducers are especially well suited for making measurements in applications where reflectors are very near the transducer, since this design eliminates the ring down effect that single element transducers eliminate. Okay, now what happens in single element transducers? These single element transducers are operating in pulse echo mode. Okay, so due to this, the element cannot start receiving reflected signals until the element has stopped ranging from its transmit function. So when there is single element transducer, okay, this operating, the signals cannot be received properly. Okay, the reflected signals cannot be received properly. So we go for dual element. Okay, what happens in this? These make the applications comparatively easier. What they make the measurements very easier. Where how? How in this what this do that the ring down effect, the you can say the single element transducer experience. Okay. Now the dual element transducers are very useful in making thickness measurement of thin materials and when inspecting for near surface defects. Okay, these are really useful when making thickness measurements. Okay. Now, they have a range? They are used only for thin materials. Okay. Now, the two elements are angled towards each other to create a crossed beam sound path in the test material. You can see how they have made the angled and how the beam has crossed and the transmitted signal has came and then received again. Now, delay line transducers. These are also, you can say, important kind of transducers, which are, you can say, vibrant and versatile in nature. Let's start with this. You have in the, you can say, in the diagram, you can see that there is kind of a rear cap, then there's kind of a delay line, then kind of a membrane in it. So we studied about all these things. So delay line transducers, they provide versatility with a variety of replaceable options. So removable delay line like surface conforming membrane and the protective rear cap options can make a single transducer effective for a wide range of applications. So as the name implies, the primary function of the delay line transducer is to introduce a time delay between generation of a sound wave and the arrival of any reflected waves. I repeat this and you should get a better idea of that. Let's say that the name says delay line transducer. So in this, what happens? The primary function of this delay line transducer is to introduce a time delay between the generation of the sound wave and the arrival of any reflected wave. There is a delay, okay, when the generation of sound wave is there and the arrival of any reflected wave is there. Okay, so this allows the transducer to complete its sending function before it starts its receiving function. Okay, so that the near surface resolution is improved. The transducers will have its sufficient time to send and receive the function. So they are designed for use in applications such as high precision thickness gauging of thin materials. See, the previous that reason was also used for thin materials, okay, for measuring thin materials. But here it is used for high precision thickness, okay, and delimitations checks in composite materials. So this has a precision in it. So they are also useful in high temperature measurement applications. Okay, in high temperature also they are these are can be used. These transducers can be used. This delay line transducer. They are also useful in high temperature measurement applications since delay line provides some insulation to the piezoelectric element from the heat. Okay, they are protected from the heat. Now angle beam transducer. Now, angle beam transducers and wedges are typically used to introduce a refracted shear wave into the test material. You can see in the diagram that there is the transducer and a kind of an you can say angle is there. Okay, the sound path is traveling at an angle theta r. You can understand that there is some kind of support. Okay, so angle beam transducers and wedges are typically used to introduce a refracted shear wave into the test material. Now the transducers can be purchased in a variety of fixed angles or in adjustable versions where the user determines the angle of incidence and refraction. Now in the fixed angle versions or the angle of refraction that is marked on the transducer is only accurate for a particular material, which is usually steel. Now the steel is also, you can say the importance of steel has been seen here also. Okay, in fixed angle versions, the refraction angle of refraction that is marked on the transducer is only accurate for a particular material. Okay, so the steel, one of the most commonly used material in the industry, maybe in commercial or maybe in the household, it has its importance. Okay, now the most commonly used refraction angles for fixed angle transducers are 45 degrees, 60 degrees, and 70 degrees. Now, so these angles are based on the experimentation data that they have from the past. Okay, these data are accumulated by them. They have came to this result and that okay, the most commonly used angles that can give you results. Can give you results are like 45 degrees, 60 degrees, and 70 degrees. Now the angled south path allows the sound beam to be reflected from the back wall to improve detectability of flaws in and around welded in. Okay, so now this is important. This has found able to found discontinuities or defects in the welded area in the welding zone. Okay, so how what they do? They allow the sound beam to be reflected from the back wall to improve detectability of flaws. Okay, in and around the zone where the welding has been done, it is able to detect the flaws. Now they are also these are also used to generate surface waves for use in detecting defects on the surface of the component. Now, see, it can be used on the surface also. Okay, so these are also used to create surface waves, but minute are easily able to find out with the help of these transducers. The normal incidence shear wave transducer. Now these transducers they are unique, they are important, they are different, they are unique because they allow the introduction of shear waves. They allow the introduction of shear waves directly into the work. I repeat, now these normal incidence shear wave transducers, these are unique because they allow the introduction of shear waves directly into the workpiece or in the test piece without the use of an angle beam wedge. Now you can understand the application. They are not using any angle beam wedge. They are straight away introducing the shear waves into the test. Now careful design has enabled manufacturing of transducers with minimal longitude wave contamination. So this is how it is. Now paintbrush transducer. Now these, as the name says, paintbrush. They have a brush and they are wide. They have space. They can measure length. So paintbrush transducers are used to scan wide area, as the name says, wide area. Now these long and narrow transducers, okay, they are made up of an array of small crystals, and that make it possible to scan larger area more rapidly for this quantity. Okay, now the how this is helpful. These are long and narrow transducers. They scan wide areas. Okay. So you can say the larger areas easily can be scanned with the help of paintbrush transducers. And why we are scanning? We are scanning for the defects, the discontinuities. Okay. Now the smaller and more sensitive transducers are often then required to further define the details of a discontinuity. Okay, so you need to know the details of this. Now this is a simple diagram showing a couplant. Okay, the couplant one of the most important thing in ultrasonic testing. You can see the transducer, the contact transducer that is there absent, and there is a test material or the workpiece in the bottom, and between them there is a couplant showing in the diagram. So let's discuss about the couplant. The couplant is a material usually liquid that facilitates the transmission of ultrasonic energy from the transducer into the test. It is generally necessary because we can say acoustic impedance mismatch between air and solid is large. So it minimizes this, you can say, this mismatch between the air and the solids. Okay, so you can say it helps the transmission of these kind of energy, like ultrasonic energy, from the transducer to the test specimen. The purpose is to transmit the ultrasonic energy from the transducer to the test specimen, and it helps this couplant help in better transmission. Now, therefore, nearly all the energy is reflected and very little is transmitted into the test material. The couplant displaces the air and makes it possible to get more sound energy into the test specimen or test workpiece so that a usable ultrasonic sound or ultrasonic signal can be obtained. You can understand how important it is. Okay, it is helping. You can say to you can say wastage of the sound energy. It is helping to avoid the wastage of the sound energy. Okay, so nearly all the energy that is reflected in this, okay, and very limited is transmitted to the material where couplant is not used. Now, when the couplant is used, the couplant displaces the air and makes it possible to get more sound energy into the test specimen so that a usable ultrasonic signal can be obtained. Now, this ultrasonic testing, okay, you can go in this. The couplant is really important. Okay. Now, what we just studied before that couplant is mainly a liquid. So, in the liquid, you can say that either water will be used or either some oil can be used, like some synthetic oil, or a glycerin can be used. Okay. So, in contact ultrasonic testing of a thin film of oil or glycerin or water is typically used between the transducer and the test surface or the workpiece surface. Okay, between the test surface or between the transducer and the test surface or the workpiece. Okay, now when shear waves are to be transmitted, fluid, the fluid in there, is generally selected to have a significant viscosity. Okay, now when scanning over the part, immersion technique is often used. In immersion ultrasonic testing, both the transducer and the part are immersed in couple. This is typically water. Okay, what they do? They go for immersion. So when we are immersing in it for ultrasonic testing, or you can go for immersion ultrasonic testing. What they do? They take water as a, you can say, immersion, and sorry, water as couplant, and they immerse. They take water as couplant and they immerse the part and the transducer. This method of coupling makes it easier to maintain consistent coupling while moving and manipulating the transducer. Or so in this way, this coupling is helpful. Now the pulsar. Okay. Now we have studied about coupling in detail, couplants or couplet in detail. Okay. Now for the pulsar or receivers. Now ultrasonic pulsar or receivers are well suited to general purpose ultrasonic testing. Okay. You can see in the diagram the pulsar receiver there is a link between the transducer and there. This also is linked with the computer or scope display. Now, these ultrasonic pulsar receivers are well suited to general purpose ultrasonic testing. Along with the appropriate transducers and an oscilloscope, they can be used for flaw detection and thickness gauging in a wide variety of metals, plastics, ceramics, and components. Okay, these can be used for flaw detection and thickness gauging in a wide variety of metals. Now, ultrasonic pulse receivers provide a unique, low-cost ultrasonic measurement capability. These receive a unique, you can say, a low-cost ultrasonic measurement capability. Now, uh, see, uh, you can see the name say pulsar. So you can see that they have specialized portable equipment that are dedicated for ultrasonic inspection. Merge the pulsar receiver with the scope display in one small size battery operating. So this is an another, you can say, application. Now the pulsar section of the equipment or the instrument generates short, large amplitude electric pulses of controlled energy. Okay. The pulsar section of the instrument will generate short, large amplitude electric pulses of controlled energy, which are converted into short ultrasonic pulses when applied to an ultrasonic transducer. Now, control functions associated with the pulsar circuit include like pulse length or damping. Okay, the amount of time the pulse is applied to the transducer. Then pulse energy, the voltage applied to the transducer. Typical pulsar circuits will apply from 100 volts to 800 volts to a transducer. So this pulsar is here you can say it is uh, very important you can say equipment of this ultrasonic testing. Okay, now this is you can say one of the important thing. Why? Because you can say the pulsar section of the instrument they generate short large amplitude electric pulses of control energy which are converted into short ultrasonic pulses. Okay, when applied to ultrasonic and transducer, and you can say that this has lead you can see for proper this will lead to proper functioning of the ultrasonic testing. Okay. Now in the receiver section, the voltage signals produced by the transducer which represents the received ultrasonic pulses are amplified. The amplified signal is available as an output for display or capture or signal processing. Now there are control functions associated with the receiver circuit that include signal rectification. The signal can be viewed as positive half wave, negative half wave, or full wave. Shown you previously in the diagram also the you can see the waveforms are coming as an output. Okay, so the it can come as a positive half wave or negative half wave or full wave. Now filtering to shape and smoothing and gain or signal amplification of the reject control. Okay, so the signal that we are receiving it can be amplified. The amplified signal is available as output for display or capture for signal processing. Okay, so that's again the same diagram that you can see. Now there are calibration controls. Okay. Now what is calibration? Calibration is also important because you have to calibrate what you are getting. So calibration is an operation of configuration the ultrasonic test equipment to known values. So calibration, this standard comes in a wide variety of material types and configuration due to diversity of inspection application. Now there are following types of calibration standard like pulse. The first one is normal beam inspection. Normal beam inspection. Now in this what happens the pulse echo ultrasonic measurements can determine the location of a discontinuity in a part or structure by accurately measuring the time required for short ultrasonic pulse generated by a transducer to travel through a thickness of material reflected from back to or the surface of a discontinuity and be returned to the transducer. Okay, now this is helping to find out the discontinuity, okay, or defect in the part. Okay, so what is doing? It is helping to determine the location, okay, the location of the defect in the part by how? By accurately measuring the time required for short ultrasonic pulse generated by the transducer. Okay, to travel through a thickness of material. Okay, the material we know to travel through thickness of material reflect from the back or the surface of a discontinuity or a defect and be returned to the transducer. This is simple. Now in most applications this time travel is a few microseconds or less. The few microseconds. The two-way transmit transit time measured is divided by 2 to account for the down and the back travel path and multiplied by the velocity of the sound in the test. Okay, in most application, okay, you can find out the time also. So this time travel is normally a few microseconds or maybe into less. The two-way transmit time measured is divided into two to account for the down and back travel path. In this way, travel path and multiplied by the velocity of the sound in the test material. Now angle beam inspection, one more. Now these angle beam transducers and variants are typically used to introduce a reflected shear wave into the test material. You can see an angle sound path allows the sound beam to come in from the side, thereby improving detectability of flaws in and around welded area. Okay. We studied previously also about this angle beam inspection. Now angle beam inspection is somehow different than the normal beam inspection. Okay. In normal beam inspection, what happens? The back wall echo is always present on the scope display. Okay. And when the transducer passes the discontinuity, a new echo will appear between the initial pulse and the back wall echo. Okay, so here you are able to find out a discontinuity as came because echo will appear. Okay, in the between the initial phase and the back wall echo. Now, however, when scanning a surface using an angle beam transducer, there will be no reflected echo. In normal beam, echo was there, but in angle beam, no reflected echo on the scope display until a properly oriented discontinuity or reflector comes into the bulk. Until there is a proper oriented discontinuity or reflector comes into the bulk. So they both have their own style of finding the discontinuity, normal beam and uh, angle beam inspection. And based upon the application, you can go with each of them. Now, variables that affect the ultrasonic test. Now, ultrasonic tests, you can say they can provide information about several aspects of a material, such as thickness or attenuation or shape and presence of defects, size, and the orientation. Now, these rely on two main measurements, that are the amplitude of signal and time of the signal alignment. So, to a lesser extent, the frequency content of the signal can also provide useful information, but its application is not so common. So, for this, for the test condition, we can have some assumptions and we can pre-assume that in time or amplitude are caused by the variation in the parameter of interest. Okay. Now, for example, when we're taking and performing a thickness measurement, we assume that the acoustic velocity of the test piece we are measuring is the same as the acoustic velocity in the calibration. We assume, okay, we assume and then these test conditions and then we go for the test. Now there are also temperature. So we also assume that the temperature at which the test and calibrations are made are not important. Okay, the temperature at which the test and calibrations are made are not important. Yet either or both of the parameters. We are saying earlier assuming a thing, but here also we are also assuming that temperature is also not important. At which test and calibrations are there, that are not important. Yet either or both of the parameters assumed fixed. Material velocity and temperature can affect our test results. So variables affecting the test results will be divided into four groups. First is instrument performance, second is transducer performance, third is material variation, fourth is defect variation. So these four groups have their independent performance. Now first is the instrument performance. The primary variable is the scope is the linearity of the time. Okay, so verification methods will usually require a tolerance inaccuracy to a percentage of the total screen thing, that is the result of plus minus of 2% is there. Okay, this only this tolerance is there. So this ensures no distance measured will be in error by more than 2%. Example, for a 250 mm range, it may be possible that to have error of plus minus of 5 mm maximum in steel. So only 2% of error is allowed. Now amplitude uncertainty result from variations in the linearity of the vertical deflection of the soap or due to inaccuracies in the amplitude control. Now the scope vertical linearity ensures that the relationship between two signals of different amplitudes is maintained over the entire range of the screen height. Okay. Now, this is done by comparing the relative height of two echoes at different screen heights. Example, getting two echoes at 6 decibels apart, starting with the first 80% FSH, the other as 40% FSH adjustment are made to the first increase the 80% FSH signal to 90 and 100%. So the lower signal should be 45% and 50% respectively, reducing the higher signal to 10% FSH increments. The lower should continue to be the half of it. In this way, they maintain the performance. So the tolerance for this parameter is plus minus of 5% of the screen height that we have just seen. Now this ensures the signal ratio of two different amplitudes truly indicates the size or distance effects. This implies the calibrated gain control usually found in decibel instruments or usually found in decibel increments on a fraud detector. Now since the decibel is derived from dB is equals to 20 log A2 by A1, changing the dB gain by a fixed amount should change the ratio of the signals. Now this allows us to expect a signal of 80% FSH to increase it to 100% when 6 dB is added to the receiver again. Receiver gain. Now transducer performance. The wear experienced by movement on metal surfaces tends to accelerate changes in performance. Now some of the changes introduced by wear can alter test results significantly. Okay, now how? As an example, consider beam angle change. At the start of the day, the normal 60-degree probe was found to have an actual angle of 62%. An indication is found with the sound path of 150 mm in a 100 mm thick plate but well. Okay. Now, quick calculation made by the operator allows plotting the position that defect at 122 mm along with the surface from the exit point and then 70.4 mm below the test surface. Okay. After several hours of heavy scanning, the operator was unwittingly worn the probe down to on the nose and the actual angle changes to 58%. Both 62% and 58% are within acceptable tolerances for a non-necessary probe. And when the same indication is investigated again, the you can say operator finds the indication in the same area, but it does not seem to be. The sound pass is only 130 mm for the new indication. Okay. Now the operator, believing that the refracted angle is 62% for 62 degree, now plots a defect of 62 mm below the surface. In addition to aging and environmental causes of alterations to the transistor performance, handling can also cause changes to occur. Okay, now the transistor performance. The sharp jolts from dropping a probe may result in when you drop the probe, the sharp jolts some error become. From dropping a probe may result in a dissimilar, or you can say may result in a similar disband problem with the availability of different pulse shapes. It may be possible to deteriorate polarization of in an element. A negative going pulse voltage is normally applied to probes, but polymer elements tend to perform better with positive going pulse. So polymer probes, okay, the polymer probes will show no deterioration if pulsed with negative going spikes. Okay, if there's negative going spikes, it will not show no deterioration. But ceramic elements may experience depolation with extended period of time. Now, depolation will reduce sensitivity and the increased gain required will manifest itself in a lower resolution. Let's start with the MCQ now. Now, paintbrush transducers are used to scan wide areas. Now, these long and narrow transducers are made up of an array of small crystals that make it possible to scan a larger area more rapidly for this function. What it is called true or false. It will be called as true. Okay. Now, in ultrasonic testing, these transducers they do not contact the computer. These transducers are designed to operate in a liquid environment and all connections are watertight. I told you this kind of transducer in the PPTs also. It is like something is in the liquid, something is immersed in the liquid. That is called immersion transducer. Now in ultrasonic testing, there is a section of the instrument which generates short, large amplitude electric pulse of controlled energy, which are converted into short ultrasonic pulses when applied to an ultrasonic transducer. What do we call it? We call it the pulsar. Okay, we call it the pulsar. The most commonly used refracted angle for fixed angle transducers are 45 degrees, 60 degrees, 70 degrees. Now these data has been found by experimentations, and based on that they have fixed these reflection angles. Now the angled sound path allows the sound beam to be deflected back from the back wall to improve detectability in flaws in and around the welded area. So this is true or false? This is true. Now in ultrasonic testing, this displaces the air and makes it possible to get more sound energy into the test specimen so that a usable ultrasonic signal can be obtained. What do we call this? Thing we can understand that it is trying to between a you can say get more sound energy from the test specimen. Okay, and purpose is to form a usable ultrasonic signal. It's called as a couplet. Okay. Dual element transducers contain two independently operated elements in a single house. One of the elements transmits and the other receives the ultrasonic signal. What is it? This is true or false? This is true. Now in this testing, both the transducer and the part are immersed in the coupling. This is typically what the method. This method of coupling makes it easier. This method of coupling makes it easier to maintain consistent coupling while moving and manipulating the transducer. So what do we call it? We call it an immersion ultrasonic test. Now in UT, these are caused by the direct contact infection and are generally hand manipulated. These are used for direct contact specific infection and are generally hand manipulated. They have elements protected in a rugged casing to withstand static contact with a variety of materials. What do we call it? The contact transducers. Now in ultrasonic testing, okay, the coupling materials of water, grease, oils, or commercial materials are used to remove the air gap between the dash and the component being inspected. What do we call this? We call this a transducer. Why we are doing this? For proper flow of signal. For proper flow of signal inside. So coupling material we can say of water, grease and oil or commercial materials are used to remove the air gap between the transducer and the component being used or component being inspected. Okay, the component being inspected that depends on that. Now as the name implies the primary function of a delay line transducer is to introduce a time delay between the generation of the sound waves and the arrival of the reflected true or false. This is true. So far we studied about the various types of transducers like contact transducers, immersion transducers, angle like we have angle transducers. So these all transducers should be known to you, should be you should have a right small knowledge about them also. That what actually the types of you can say transducers they are used. Then we went for the couplant and its working, that how this works. Then types of couplants like water, grease, oil, all these all were discussed and uh, then discussion was done on them also. So after this, you can go with the references if you want. These are some references which you can refer and understand the lecture better so that our doubts will be clear. Moreover, if you want to have more diagrams regarding these topics, then also you can refer these books, these references. If you want more content also, then this also book is these books are very important. Okay. Now, never fear that books. Okay, the language will be tough or not. Always try to read the text. Always, okay. Okay, while reading and more practicing, then only you will able to learn or understand that language because every author has a particular style of writing. Every author has a particular style of writing. So you have to go with the flow. Okay. So I hope you refer all these references for your help and for your better guidance. Thank you all for now.